The final thing we'll talk about for financial mathematics is perpetuities. Perpetuities are annuities which have no end date. They go on forever. It turns out that you can reasonably ask about their present value because future values are so heavily discounted that they don't significantly affect anything. We already know that if our payments are big R and these compound with an interest rate little r, and that the terms coincide, then the present value formula is given as a large summation, as follows. Now, because this is a perpetuity, instead of stopping here, we're actually going to go on forever. And in sigma notation, this becomes an infinite sum. Now, but as before, the R term doesn't really affect anything, so we're going to pull it out. And this is still a geometric series, but is now an infinite geometric series. So we know a formula for evaluating an infinite geometric series. Let me write it down to remind you. And our common ratio is still 1 plus r to the negative 1, as it was in the present value of an annuity. So evaluating our present value of a perpetuity using the formula for an infinite geometric series gives us this. Now we've previously seen that we can write this denominator as r times 1 plus r to the power of negative 1. So if we plug that in, we get a rather nice cancellation, leaving just r over r. So the present value of a perpetuity is just the quotient of the payments by the term rate. All right, as an example, let's suppose that you want to establish a scholarship, and let's say that it pays out $10,000 every year in perpetuity, that is forever. You invest the money and you believe that you can secure a return of 5% per year to fund the scholarship. How much must you invest? Okay, and again, note that the scholarship pays yearly and our rate is quoted yearly. Well, we know that the scholarship pays out $10,000 a year and that our investments will return 5% a year, so putting this together means that we must invest $200,000 to keep this scholarship alive forever. So this is a pretty straightforward calculation, but again, make sure that you practice doing things by changing the compounding rate or the payment rate, and that you're still comfortable with being able to do these derivations.